All right, so the next little section we're going to look at ratios, and the first couple lessons are pretty straightforward, but do make sure you understand before you move on, simply because ratios are used in every single trait. So understanding how to solve a ratio is going to be quite important for us. So in this lesson, we're going to look at where ratios are used. And I'm going to get you to actually participate in a discussion that gives me a couple ideas of where you've seen ratios before. We're going to write ratios using word notation, number notation, and fraction notation. And then we're going to identify three types of ratios. We're really going to look at these parts ratios mostly. Rate ratios and percent ratios we will look at a little bit later. So a ratio is simply a way of comparing two quantities using division. Okay, so really simple. You've seen it in your car, kilometers per hour. How many kilometers per hour? That's a rate ratio that you've seen, or miles per hour. Liters per 100 kilometers. Those are all types of ratios, but there's numerous different kinds of ratios. In this particular question, we're going to look at different ways to write ratios. So if we have 1 apple and 4 oranges, how can I write that ratio? So you'll see that ratio written a few different ways. One of the ways you'll see that ratio written is in words. To write the ratio, we can say it two different ways, but we may say 4 oranges to 1 apple. This 2 tells us we have a ratio happening here. You could see it in number notation. And if you see it in number notation, the number way to write that would be 4 oranges. And I'll typically label that to 1 apple. You could also write it as 4 to 1 if there's something else in the question before that automatically tells me what the order is. Okay? You'll find for gears, there's a particular order that things are written in, so you don't have to label which is which. And then the last way we can see ratios written is in fraction form. And to see them in fraction form, we're just going to replace this colon with a division line. So we would see it written as 4 over 1. The first number is always going to be the numerator. The second, the compare to, is going to be the denominator. So in this case, we would have 4 oranges to 1 apple. Okay, so there's the three different ways you can write a ratio, and depending on what the question asks, you'll be asked to write one of those 3 ways, or you'll have the opportunity to choose. So we're going to take a look at exactly the same picture, and I want you to think about how many different ratios could we write for this fruit combination. Now I'm using something really simple to start, simply because this is a concept that for some reason every year when we work at solving ratios seems to get muddled up in class. So if you wonder why I'm starting with something simple, it's based on past experience. So we've already seen one ratio that we could write for this fruit. We could say there's 4 oranges to 1 apple. That's one way of describing the orange-apple relationship. We could also say we could flip the ratio, and that's another ratio. We could say we have 1 apple to 4 oranges. So those are 2 ratios, but those aren't the only ratios that we have. These are all fruits. So we could say, well, we have 4 oranges to 5 pieces of fruit in total. And you could do the same thing with apples. Now, there's a question that I often will come up, and you'll probably see it in SAM, and it talks about a length of a board. And you're only told certain pieces about it, and you have to think about, well, what is the other half? And you have to kind of think about these hidden ratios that you might not see, where this, from the picture, we didn't necessarily count there's 5 pieces of fruit, but maybe that wasn't the obvious comparison to do. So here we're doing the number of parts that are oranges to the number of parts that are a whole. Now we're going to look at one other example that uses this because this is a fairly common way to see a ratio come up. So this is just a graphic I have came up with. This is a very common type of problem to encounter. So this is just a dilution question. I used to do dilutions in chemistry all the time. And I guess I never really thought of them as being ratio questions. But they're pretty straightforward. So this could be an example. So here we have soap and water just because it's a graphic that I found from a website that was how to make the ideal foam soap. Now you may have pesticide you're diluting, you might have a cleaner you're diluting, and you have to be specific on your ratios. My husband deals with this all the time at work, where they're adjusting their concentrations and the ratio of polymer in order to extract waste from water. So depending on your work context, you're going to see ratios show up in many different ways, but this is a really good dilution one. For you auto students, you may be looking at how much antifreeze you're mixing with water in order to make a solution that's not going to freeze in our northern climate. So how many ratios can we write for this image? Well, it's the same as before. The really obvious one to see is 5 water to 1 soap. SOAP. Or we could say 1 soap to 5 water. So those are 2 different ratios we could write. But the other ratio that's going to be helpful for calculating, let's say I want to make 50 gallons, or maybe I want to make 100 gallons of this soap solution, or it could be any particular kind of solution. It'd be really nice to have a ratio that compares to the total. So while we know there's 5 water, that's shown in the graphic, how many parts are there in total? Well, we have 5 parts water plus 1 part soap. So that's going to give us 6 parts in total. So this would be our total solution. And these are the questions that people tend to get mixed up on. 1 soap, I keep leaving out a letter, to 6 parts total. And those parts are just equal pieces. So we say parts because those parts could be liters, the parts could be milliliters, they could be gallons, it could be pints. We can substitute different units in for what those parts happen to be, as long as both of them have the same kind of unit. All right, so there's a couple rules when we're using ratios. When we're writing ratios, the first thing is like doing fractions, because we can write them like fractions. We're always going to reduce. We're going to write them without decimals wherever we can, unless we're doing a compare to 1. So unfortunately in SAM, you're going to do a lot of decimal ratios because we're going to compare to 1. And the most important thing is order always matters. So read your question carefully. If you're somebody that flips words around, be really conscious of checking your work over and writing things down, because it will help. So let's do a few questions. I want you to write the following ratios without decimals. So I'm going to show you how to do the first one, and then I think you should find it fairly intuitive to do the others. So to get rid of our decimal, let's think about what could we multiply both of these by to get rid of the decimal. Well, we need to move the decimal 1 place, and to move a decimal 1 place, we can multiply by 10. Whatever I do to one side of a ratio, I'm going to do to the other, because I need to keep that ratio balanced. So this is going to leave us with 55 to 15. Now that we've got rid of the decimal, then we're going to reduce. In order to reduce, easiest way to do that is they both end in 5. So let's divide by 5 and see what happens. 55 divided by 5 leaves me with 11, and 15 divided by 5 leaves me with 3. That's simplest terms, and that's going to be a reduced ratio without decimals. So 5.5 to 1.5 is the same as an 11 to 3 ratio. Okay, not too complicated, pretty straightforward, thinking back to fractions. Now let's look at the next one. 7.25 to 5.4. First of all, get rid of the decimal. So we need to move this decimal 2 places. So to move the decimal 2 places, we're going to have to multiply by 100. Whatever we do to one side, we're going to do to the other. So we're going to multiply it by 100 as well. So now we have 725 to 540. The number gets really ugly when we do this. We can divide both of these by 5. So again, we're reducing. And after you divide by 5, 725 divided by 5 leaves me with 145. And the other side, 540 divided by 5 leaves me with 108. And I have already checked. You can do a check for yourself, but that's the lowest terms that we can go. Next one, we have 3.6 to 0.6. So you can use the 2 where we can replace this 2 with our colon. So again, we're going to multiply by 10 on each side. So we'll have 36 to 6. We'll reduce, so I can divide by 6 on both sides, and we would get 6 to 1. 3.6 to 0.6 is a little bit of an awkward ratio, but 6 to 1 is a really easy ratio. You can do a lot of head math with you using a 6 to 1 ratio. It's much easier numbers. So that's one of the reasons why we try to get rid of decimals if we can. We'd rather see our ratios written in these forms, but it's quite easy for us to do. All right, next question we're going to look at, we're just going to take some word problems, we're going to write some simple ratios from them, and I'm going to give you a tip for how Sam's going to expect you to put an answer in when you see a question like this. The Honda dealership has 82 cars in the lot. Only 26 of those cars are a brand other than Honda. What's the ratio of Hondas to other brands? Write the ratio in number or fraction form. So you have 2 different ways you can write them. So what we're looking for, and it might be best to kind of pull that out, is what's the ratio of Hondas to other brands? So we're looking for a ratio in this order, Honda to other, on this car lot. So if we look through the questions, let's find out what our numbers are. So they have 82 cars. That's their total. 26 are another brand. We don't know how many are Honda, but we can calculate it. 82 minus 26 leaves us with 56. So 56 Hondas 2, and we don't have to label what it is because the word problem has told us what they are. So if the word problem says it's Honda 2 other, if you say 56 to 26, that's automatically telling us the ratio. And then we need to reduce it. So to reduce it, we're going to divide both sides by 2. And that's going to leave us with 26 to, oops, let me erase here. Find my eraser. Helps when you write the right numbers down. So 56 divided by 2 is going to leave me with 28 to 13, or if you wrote it as a fraction, 28 over 13. Okay. If you wrote 13 over 28, you've got your order backwards. There's not 13 Hondas to every brand. That would be saying they have more other brands in their car lot. So that order tells the story. It's important to have that order in the right direction. Now in SAM, it's going to say write the ratio as a ratio compared to 1. Well, how do we do that? So they'll say, okay, you've got your ratio of 28 to 13, and Sam wants that to be something compared to 1. Well, how do I turn 13 to 1? Well, we divide it by 13, and whatever we do to one side of the ratio, we're going to do to the other side of the ratio. So we'll take our 28 and divide it by 13, and we would get 2.15. Okay, so that's how we could do a ratio compared to 1, is start it with this ratio. The 2, 1 is always going to be the second number, has to be equal to 1. So whatever your second number is, you're going to divide both sides by that. So 13 divided by 13 leaves us with 1, and 28 divided by 13 gives us 2.15. This is what you're going to enter in SAM. Okay. So that's what you're going to enter for your SAM answer, unless it happens to be a multiple choice that allows you to do the colon notation. But for pretty well any of the calculate questions, if it says write as a ratio compared to 1, all you have to do is write the number that's not a 1, because SAM doesn't handle this part of the ratio very well. All right, let's do another couple questions quickly. Oh, this is a great one, and this is a question that will show up for you. A board 5 feet long is cut into 2 pieces. One piece is 40 inches long. What's the ratio of the short piece to the long piece? So, okay, so we want to know, let's write out what our ratio is. Now, I like to write it in words. We want to know the short piece to, so short to long. Now, I have a tendency to flip things, so if I write this out, it will help me keep organized. Now we have to find out our pieces. So we have our total is 5 feet. Piece 1 is 40 inches. Piece 2, well, we got to figure out how many inches that is. So 5 feet times 12 gives me 60 inches. So 60 inches is the whole thing. One piece is 40, so that leaves us with 20 inches left. So piece 2 is just 60 minus 40, which gives us 20. Okay, so if you want to write our ratio, the short piece is first. So we have a piece that's 20 inches long. I have a long piece that's 40 inches long. And then we need to reduce. So I can divide both by 20. And this is going to give me a ratio of 1 to 2. Okay, nice and easy when we write it as a ratio compared to 1. So 1 to 2 is equal to something to 1. So in order to do that, I'm going to have to divide that by 2. 2 divided by 2 will give me a 1. And then 1 divided by 2 gives me 0.5. 0.5 to 1. So this would be our answer in SAM. All right, just a couple more. Fuel for a 2-stroke engine was mixed using 5 liters of gas and 100 mils of 2-stroke oil. What's the ratio of gas to oil? This is one of the questions my husband, every time I say I'm doing ratios, my husband says, make sure you ask him that question. Because I guess it's something he does every time he pulls out the chainsaw. I don't use this very much. So we need 5 liters of gas and 100 mils of oil. What's the ratio of gas to oil? So let's start that. We need gas to oil. And if possible, we want to use the same units. Now, if you wrote 5 liters to 100 mils, we could do that, but that doesn't quite as nice a number. Typically what we'll do is we'll say, well, we've got 5,000 mils, convert the liters to milliliters to 100 mils. And if you divide both sides by 100, it gets rid of 2 decimals on each, so we have a 50 to 1 ratio. Now, if you ask him what's the mixture for his chainsaw, he's going to tell you it's a 50 to 1 ratio. That means if we're using matching units, you use 50 parts gas and 1 part oil. If we're writing it, and this is already done, it's already as compared to 1, 50 to 1, the 1's already there. All right, so it's quite simple. I always try to make the units match whenever we can. And just one last question for you. And it's a nice, easy question for us. A gear with 48 teeth is driving a gear with 36 teeth. What's the ratio of the driven gear to the driving gear? Now, this is the order in which the ratio is typically always written. And I'll admit, I often have to look it up. I struggle to remember what order, and it's a left-right dyslexic thing that I have. So the driven gear. So which one's the driven gear? Well, let's look back at the sentence. A gear with 48 teeth is driving a gear with 36 teeth. So 48 teeth, this is my driver. So that must mean the 36 is the driven. Okay. So what's the ratio of the driven gear? That's first. So 36 to 48. And then we reduce it. So we can divide both of these by 12. 36 divided by 12 gives me 3. 48 divided by 12 gives us 4. So it's a 3 to 4 ratio. And we'll often write these as ratios compared to 1. So 3 to 4 is equal to what? To 1. Well, we'll divide 4 by 4, divide 3 by 4. And 3 divided by 4 leaves us with 0.75 to 1. Okay, and we'll use those ratios in the future for doing some other calculations.